Hello everyone, welcome back to our today's video, which is part 3 of quantitative risk analysis. In the previous two videos, we have talked about influence diagrams, expected monetary value, and decision tree analysis. Today, we will be taking up Monte Carlo simulation, which is an advanced risk analysis technique. And once again, using this type of technique requires specialized tools, people, and a lot of data as well. For the sake of this discussion and understanding how this technique is used, we are going to keep it as simple as possible, and we just will try to understand the gist of it, that what exactly this technique is doing. So first of all, it's a simulation technique, which means we are trying to build thousands of scenarios. It's like, what if this happens? What if something else happens? What if something else happens? So every time we run a scenario, we get a different outcome. Say for example, scenario 1, I am considering that there might be a specific risk that happens, and because of that risk there are possible delays in the project. Now, considering that we don't know exactly how much delay a risk can result into, literally, like you may say that for example, if the vendor ends up delivering late, we possibly will have an impact of 5 days of delay. But who knows that will it be 5 days, will it be 6 days, will it be 4 days of delay? We cannot say that with 100% confidence. So that's what we are trying to statistically derive that, say for example, in scenario 1, considering the different risks that can materialize, we say that the project will finish possibly on 30th of December. That's just one scenario. Then we take another scenario with different variables. Randomly we keep changing the variables, and this time the schedule calculation reveals that the project can finish on 28th of December. Then we build, this is not literally that we are manually doing these scenarios. Generally, there is a simulation tool, and it will keep running these scenarios automatically by randomly changing certain variables that you tell it to. So every time the simulation runs, a different end date is calculated, and then it just keeps going on and on and on and on. Like these are just 4 scenarios, but understand that I could be looking at 10,000 such scenarios, and every time every scenario gives me a different end date to the same project, because of the different variables that the system is randomly changing. Now, what's the advantage? Like, why are we doing this? Once you have possibly 10,000 or 20,000 different scenarios, using this data set, we can find out that what is the average. Let's say the average end date is maybe 3rd of January. So this seems to be a pretty confident date, considering that we have taken into account 10,000 different possible scenarios, and out of those 10,000 scenarios, the average end date is 3rd Jan. But we can go further also. We can say that, okay, if this is the average, then maybe we can figure out that more than 70% simulations revealed an end date of 5th Jan or before. So now we can say that we are 70% confident that the project can finish before 5th Jan. We can take it further and we can say, okay, let's see what 95% of the sims are saying. So now we can easily find out that, okay, 95% of the simulations revealed that the project end date will be 20th Jan or before. And you can just keep going in this manner that we can find out that how many percentage of simulations revealed what end date. And this gives us a pretty good confident estimate in terms of how soon or when the project can be finished realistically. Once you have done this, or once the experts have done this type of analysis, this can also be presented in form of a simple bar chart, where we can say that on the x-axis we are having the different end dates, project finish dates, and then we can have bars representing various different possible end dates. Like, say for example, 500 simulations revealed an end date of 15th December. Then 600 simulations revealed an end date of 20th December. And likewise, we can just keep plotting the bars, and this would most likely come in form of a bell curve. Yeah, that's not very good. But yes, it would come something in that format. So yes, I just brought one image from the internet, and you can see that on this one, it's exactly the kind of example I was explaining you with, that this is the bar chart and it has got 10,000 trials or 10,000 simulations that it has conducted. And then the bar chart is simply showing that how many simulations calculated what end date, delivery date in this case, and the whole thing is like a bell curve. And of course we can see that 30% of the simulations revealed an end date of before 8th or 9th May, whatever it is. 50% of the simulations revealed an end date of 15th or 16th May or before that. And on the far right, we can see that 95% of the simulations revealed an end date of 15th or 16th June or before. So that's exactly how we can use Monte Carlo simulations in respect of risk analysis by factoring various different possible variables and randomly changing them to see the impact on our project objectives. I hope this video made sense. If you have any questions or confusions about this, please don't hesitate to put them in the comment box. I'll be happy to revert back on that. That's all for today's video. That's what we're going to, that's what we were supposed to cover in this video. Next video, we will be making on sensitivity analysis and tornado diagram, which will be the last part of quantitative risk analysis. That's all for today. Take care. Bye.